today is part 2 of the tutorials, and today we're going to be covering Bell states. A Bell state is a maximally entangled state in quantum mechanics. They're very useful in cryptography and in communication protocols, so it is very important that we know what they are and how they're used in Qiskit. So we're going to do that today. Before we get started, the first thing we need to understand is what a Kronecker or tensor product is. Okay, so this is basically what it's going to do. It's going to allow us to couple two states together. You take your tensor product of your two matrices. So what we're going to do is we're going to have our two states. We're going to couple them together using our product, and then from that we can calculate our Bell states. So what it's going to do is take a state, let's say 0, and if I take the product, the Kronecker product of this, in our state, I'm going to get a 2-qubit state. So this. So what we've done is enlarge our matrix to a much larger 2-qubit state. What this is going to do takes our single qubit state and puts them into a 2-qubit state. This is important because in our circuit, if I have a, say I create a new circuit. I'm going to have, let's say, called Q0 and Q1. So what I've done essentially is creating a 2-qubit state. So what we've done basically is create this state so far. So our Kronecker product here creates our 2-qubit state, and by creating a new circuit empty with 2 qubits, we've essentially created this 2-qubit state. Now how does this relate to our Bell states? Okay, so now what I'm going to do is list out the 4 Bell states.
I was right and you were wrong. I should have known it all along.
So now we have our... Okay, so these are the 4 Bell states. So why are these important? Okay, so these are maximally entangled states. We want to find a way in Qiskit to construct these. Now, what is the way we can do this? I can construct them out of my Kronecker products. Now, how is that going to look and why is that important? We'll get to that. Before that, I need to go over 2 things first. So from the last video, we went over C0. So basically the C0, what it does, if our control is 1, we flip our target. So this is the first thing you have to understand. If C is 1, flip T. Now, this is here, so if you forgot, you can go to the last video and check this out. This is the first concept to understand. The second one is new. This is the Hadamard. So what the Hadamard does,
I was right and you were wrong.
for the Hadamard gate, what we want to do is think about superposition. Okay, now what is superposition? Superposition is a way of describing a state that is basically not one or the other. It's basically both. Let's say, hypothetically, our state is 0 or it's 1. What we want to do is describe a state where it's both 0 and 1 at the same time. Now, this is a very general description. It's a lot more confusing, but I'm going to stick with a very simple explanation. What's going to happen is that I'm going to map this to 0 plus 1 over square root 2. What this is doing is mapping this state into a superposition state of 0 and 1. Okay. Now, this is going to basically be a rotation on the block sphere. We can go into that later. I'm planning to do a video on block sphere rotations. Right now, all I need to know is 0 goes to the 0 plus 1 over square root 2 state, and 1 goes to the 0 minus 1 over square root 2 state. And if you want to know a little more, this is actually going to be the 0x state. If on the box here it's pointing in the plus x direction, this is going to be pointing in the minus x direction. So that's for later. Now, what is the next step? What we want to do is construct our Bell states. Now, if you notice, this is very similar to this. It's almost as if they are located within these states. So we want a way to pull them out, or kind of separate them first and then bring back together. So what we're going to do is use our Kronecker product and our C0 to construct these. Let's do that right now. So imagine we had our circuit and we filled it with 2 qubits. qubits. We have our 0, 0 state. So in Qiskit, this is basically going to be an empty circuit of 2 qubits, right? Now, if I map this qubit here to a Hadamard, what's going to happen is that it's going to become this. Now, why is this important? If I were to couple this convert to a 0 state, if I were to couple this to a 0 state, what would happen? It will become this. Cool. Okay. So let's take a stop for a second. What we've done, we said I want to get to here. Okay. I've initialized my circuit to just 2 qubits. They're both empty. It's 0 and 0. What I want to do is take this qubit here and put it into a Hadamard state. Put it into a superposition state. So I'm going to take this first one into the Hadamard, the 0 plus 1 square root 2, or the plus x direction, right? Then what I'm going to do is couple it with another 0 state. So this state, basically, I'm going to product it with another 0 state. I'm just going to put this into here. So if you notice, this 1 here is very pesky because I want this to be 1, however it's not. So what we can do is say, look, now I'm going to do is apply my C0 gate. So the C0 is going to look at the control and targets, okay, and ask itself, okay, is this 1? No, so we leave the target alone. Okay, so this is good. Is this 1? Yes, this is 1. So we change this to 1. So this is going to become 1, 1. What we've done so far is we've gotten from here to our 5+ state. Let's look at this circuit in Qiskit itself. This is the H. Okay, we apply the H to it. So we got this one, this qubit here, to this. Then we're going to apply our C0 gate. That's it. So that's the first state done. So let's do this one. Let's do 5 minus now. Now, what is the main difference here? The minus. Okay. Now, how do we get a minus sign? What is the minus? What does that mean? So the minus basically is the phase. So basically, what all we want to do is change this to minus. Okay. And how do we do that? We do that using our phase flip gate, Z. All you need to know is that the Z gate basically affects the phase. All we have to do is change the sign of the second state here. And we can do that just by applying a Z here. So this is going to be 5 minus. Now let's do the third one now. Third one. This one. Okay. Now, this is a bit trickier. So earlier we had just a 0, 0, okay? But now we want 0, 1. So how do we fix that? Simple. Just apply the X gate, right? So the X takes 0 to 1 and 1 to 0. Right? It rotates about the x-axis of the box field, right? Now, why is that important? This is important because for our initial state, we wanted 0, 1, but here we have 0, 0. So what we can do is apply an X gate to this qubit and get 0, 1, which is square root 2. Now, how can I get this to this? Let's think about that a little bit more. I want to get this to this. How can I do that? Okay, this 0 is fine. This 1 is not working. This 1 is fine. At 0 is fine. Okay. How can I get this to this? Let's think about this a little more. So, what I could do is think, I want to get this to 1 and leave this. Okay. So maybe the first thought you had is like, why not do a C0, right? It might look like that's a wrong idea because it's become 1. However, in that case, if this becomes 1, okay, what can we do? We can apply an X gate to the second qubit, make this 1 and this 0, and get our state, right? Make sense? Okay. Awesome. So we're here. Now the question is, what do you next? We have our state, we have our C0, so what we're gonna get now is this. Let's bring it down here. We're gonna get 0, 0. If it's 0, nothing happens, right? Plus 1, 1 over square root 2. Now, we're almost there. I wanna get this to this. How can I do that? Simple. Let's change the second state to the other one. Simply flip the second qubit state. It's gonna get 0, 1, and then 1, 0 over square root 2. Good. So let's do that. Apply second the cascade. The circuit, right? If I want to get this one, what's going to happen? I want to get the +2 minus sign, right? Last step, the last state. This is not the right notation, but just to make it more logically make sense, you technically could put the z here, but let's just extend it so it kind of makes more sense to my logical process here. So that's it. Thanks for watching. That's the entire video. Appreciate it. We went over the 4 Bell States, so yeah, that's it. That's the first.